Question number 7. A uniform pressure. 1 minute, just 1 minute. A uniform pressure 7 times 10 power 5 Newton per meter square is applied to all 6 sides of a copper cube. What is the percentage of the change in volume of the cube? The change in volume is delta V. We can calculate it from the strain. So we have to know this question is very similar to the question we just calculate. He wanted to know the change in the length, so we have to calculate the strain. It's very simple. Bulk is modulus. Just 1 minute. Bulk is modulus is equal to pressure over strain. If we don't know the pressure, the difference between pressure and strain, let me see this and summarize this, and I will leave a link of a video in the description box for organic chemistry tutor. Bulk is modulus is equal to pressure over strain. What's the difference between pressure and strain? Stress when you apply the force in one side of the solid or of the thing that okay. Pressure when you apply the force in all sides. This is the difference. We have bulk is modulus is equal to pressure over strain, and we wanted to know the strain. Strain is equal to stress over bulk is modulus. Strain is equal to stress over Young's modulus. Stress over Young. So this is a result. I don't know what I wrote 3s. Stress over Young's modulus or pressure. Here we talk about bulk. So I'm so sorry. It's bulk is modulus. It will to be more accurate, just and pressure, not stress. The pressure he gave is very simple question. He gave us the pressure and give the givens 7 times 10 power 5 over bulk is modulus is equal to 14 times 10 power 10 power 10. This is the string. Okay, but he wanted to know so the ratio is 5 times 10 power negative 4. This is a string, but he wanted to know the ratio, or so we have to multiply it by or divide it by 10. So after do this, the result will be equal to 0.5 times 10 power negative 3. 10 power negative 3. Negative 3. The point is to find the choice that is equivalent to your result. The 0.5 times 10 power negative 3 percentage is equal to 5 times 10 power negative 4. Simply. Question number 8. One bar has a Young's modulus that is bigger than bar 2. This indicates that we have 4 choices. The most or the accurate one is number D. Is made of materials that is different from bar 2. Young's modulus is constant for every material. When Young's modulus is less or more or bigger or anyway, the important is that different. It's different from the other one. So the two materials are different. Let us discuss first three choices is bigger than bar 2. What is the relation between this? What this? Has a greater cross-section area? No. Has a greater elastic limit? What is no, no, no. The most accurate one is D. Okay. Oh, this question. Oh my god. This question has a trick. Consider two steel rods. A and B. B has 3 times the area and twice the length A, so Young's modulus for B will what factor times Young's modulus for A? A lot of givens, twice, 3 times, blah blah blah, but you may forget something. Two steel rods. They are made of steel. Young's modulus is a constant for every material, so the ratio between them is 1. You will not calculate anything. You will not use these givens. No, those steel rods, they have the same Young's modulus. When divide the same number over itself, it would give you 1. Just, I hope you understand this. Just 1 second. Okay. A tire stops a car by using friction. What modulus should we use to calculate the stress or the strain of the tire? We will choose shear modulus. Shear modulus when you apply a force that is parallel to the solid or to the thing you apply the force on it. The force of friction is parallel to the car, so the answer is C, the shear modulus. Okay. Question number 11. He wants to know the force. If you want to know the force, we first have to know the stress, and if we want to know the stress, we will use Young's modulus. So Young's modulus is equal to, he give us the strain. Strain here is 100%. 1%. Okay, 1% is equivalent to 0.01. Okay, so we will, instead of using 1%, we will use 0.01. If you want to use 1%, okay, use it, but don't forget to write the sign of percentage on the calculator. I'm sorry, I'm a little bit sick. So, Young's modulus. Young is modulus is equal to stress over strain. So by substituting, we will find stress is equal to Young's modulus times strain. Stress. What? Oh, is equal to Young's modulus times strain. Young is equal to 2 times 10 power 8, 10 power 8, 10 power 9, sorry, 10 power 9, sorry, 2 times 10 power 11. Give us in the questions, the givens. Times the strain is, as I just said, 0.01. So the stress is simply equal to 2 times 10 power 9, 10 power 9 Newton per meter square. I'm sorry. Per meter square. This is the stress. He wanted to know the force, so we have to know the area of the cross section. The cross section area as stress is equal to force over cross cross-section area is equal to. If we wanted to know the force, we have to know stress, and we calculated, and we have to know the cross-section area. The cross-section area is a circle, so first we have to know the area of the circle. Area is equal to 2 pi, which is 3 times, 2 times 3.1 times r, which is a radius. Here in the question, he gives us the diameter in millimeters, so we have to calculate the radius in meter. The diameter is 2, so the radius is 1 millimeter. The radius is equal to 1 millimeter, which is equal to 1 times 10 power negative 3 meter. 10 power negative 3 meter. When we want to convert from millimeter to meter, we have to divide the millimeter by 1000, or to multiply it by 10 power negative 3. So this is the radius. So the area is simply equal to, by substituting this rule, I'm sorry, the area is not 2 pi r, it's pi r square. I'm very sorry. By r square. I'm very, very sorry. By substituting this rule, 3.14 times r square. R is 1 times 10 power negative 3. All of this power 2. By using the calculator, the result will be 3.14 times 10 power negative 6 meter square. 10 power negative 6 meter square. So this is the area. So we have the stress and the cross-section area. So we can calculate the force. Force is equal to stress times area times area. Stress is, we just calculated, 2 times 10 power 9, and the area we just calculated is 3.14 times 10 power negative 6. So the force simply equal to force, this big number, 6 to 0.7, which is approximately 6.3 when you write it by the scientific notation, times 10 power 3 newton. So this is the answer. I hope you understand it. Here the question says, this question number 12, the standard kilogram in platinum whatever cylinder, 39 millimeter in height and 39 millimeter in diameter. What is the density of the material? It's very, very easy question. He wanted to know the density. Density, we all know the rule of density. Density is equal to mass over volume. Density equal to mass. Let me abbreviate this, mv. The density P is equal to m over v. So the mass, we have the mass 1 kilogram, but in the choices he doesn't use the gram, he used the gram, so we will convert from kilogram to gram. He said in the question the standard kilogram, which mean 1 kilogram, so m is equal to 1 kg is equal to 1000 gram. This is the mass. The volume of a cylinder It's very easy to calculate it. First, we have to convert it from millimeter to centimeter cuboid. As in the searches, he didn't use the millimeter. He used the centimeter cuboid. So the height is equal to convert from the height is equal 39 millimeter, which is equal to 3.9 centimeter. To convert it from millimeter to centimeter, we have to divide the millimeter by 10 to give you the centimeter. This is the height. Also, the diameter have the same thing. I hope my spelling is correct. 3.9 centimeter. This is the diameter. Okay. So the rule to calculate the volume of a cylinder is the volume for a cylinder, to be more specific, by, which is 3.4 r, which is the radius, power 2 times height, which is which h. He didn't give us the radius, he gave us the diameter. So radius is equal to the diameter over 2. So the radius is 1.95 centimeters, which is the radius. Let us substitute in by this rule. 3.14 times r, which is 1.8 95 times that square times the height, which is 3.9, which is equal to, this is the result, 46.57 centimeter cube. This is the point. Let us go to the final step to calculate the density. P is equal to m over v. The mass is 1000 gram over the volume is 46.57 is equal to the density simply is equal to 21.5 gram per centimeter cube. So the answer is A. I hope you understand this. Oh, this question. The quantity pressure expressed in terms of fundamental quantity, mass, length, time is equivalent to. So here he wanted to know dimensional formula for the pressure. Pressure is equal to force over area. The dimensional formula of pressure is simply the dimensional formula for the strain. So let us return to question number 3. Yes. Sorry, question number 4. The dimensional formula for the stress is ml power -1 t power -2. Stress is equal to force over area. Pressure, the same thing, the same steps, is the same result. So in the question we sorry, my laptop is very boring. I'm very sorry. Question number 13. Yes. The answer is also B by the same rule, by the same steps in question number 4. Okay, the answer is B. ml power -1 t power -2. Okay, this make it bigger. I hope you see the question. Let me make it bigger. Okay. pressure inside a commercial airline is maintained at 1 atm, which is equal to 10 power 5 Pascal. What is the net outward force exerted on am? 1 meter times 2 meter cabin door. If the outside pressure is 0.3 atm. Very easy question. The net pressure or the total pressure is equal to the pressure inside minus the pressure outside. So let us pressure is equal to pressure inside Pi minus Po, which is pressure outside, is equal to 1 minus 0.3 is equal to 0.7. 0.7 minus is equal to 0.7 atm not Pascal. Okay, this is the pressure. So we have to convert it from atm to Pascal to continue our calculations, as Pascal is equal to Newton per meter square. So pressure is equal to 0.7 times 10 power 5 times 10 power 5, which is equal to 7,000 Newton Pascal or Newton per meter square. Newton per meter Newton per meter square. Newton per meter square. This is the pressure. We wanted to calculate the force. Pressure is equal to force. Pressure is equal to force over area. Is equivalent to. So if you want to calculate the force is equal to pressure times area. Force P times A, which is the area, which is equal to 7,000 times the area. The area is simply 1 times 2. He gave us as a question. The dimension of the door. 1 times 2. So the area is 1 times 2, 2 meters square. Is equal to. Is the result. Newton. So this is the result. The answer is D. I hope you understand this. Okay, don't be confused from the way he gave you the question, a high vocab or nothing if you don't speak English fluently. You have the area, you have the force, you want the pressure. Very simple. Pressure is equal to force over A. But the only point in the question is to convert it from 0.5 centimeter square to meter. How we can do this? To convert from centimeter square to meter square, we have to divide the area by 100 times 100. Why? If you want to convert from centimeter to meter, you will divide the centimeter by 100. Okay, if you want to convert from centimeter square to meter square, we will divide the area over meter over 100 times 100. Okay, if you want to sorry, if you want to convert it from centimeter cube to a meter cube, you will divide the volume by 100 times 100 times 100. It's very simple. So area is equal to 0.5 centimeter power 2, which is equal to 0.5 arc 0.5 over 100 times 100 Okay, in this way, actually in this way, it will give us the result in meter. So the result will be 5 times 10 power negative 5 meter square. This is the area. So pressure is equal to force over area, which is equal to the force he gave us in the question is 45 Newton over the area is 5 times 10 power negative 5 meter square. So whatever the result will be this. Yes, Newton per meter square. That is the result. I hope you understand this. Very easy question.